Here we are looking at example 4a from the 1.3 number 27 notes, but before we dive into that, we're going to look at two special trig functions that will kind of help us out in determining a lot of the problems for example 4. Now, when we just look at a here, we see that we have the limit as x approaches 0 of the sine of x divided by x, and that's equal to 1. Well, if you recall back to your 1.2 notes, we actually already saw what this graph looks like and, in fact, what that limit looks like, and then it was, in fact, equal to 1. Now, there is a little bit of a twist, though. Just kind of taking this to the next level, if I was to go ahead and throw like a number in front of this x for the sine part, let's just go with like the number 2. So if I just put a number 2 in front of that x, thus making it the sine of 2x, divided by, and if I also put the same exact number on the bottom, right next to that x, then it will in fact still come out to be the exact same limit being 1. So again, if these numbers match like that, you should end up with that same exact limit. And again, that's going to help us out for like problem 4 especially. Now, if you're still kind of like, well, I'd like to really verify and see that, we can just go ahead and take our graphing calculator out. Here, I've already gone ahead and plugged in the function, and you can in fact see that it does approach that same exact limit. So if I just go to y equals, that's what you would type in your calculator. You can even see that number right in front of the x's. And this works, again, for any number like 3, 5. As long as they are matching, you should end up with that same limit being 1. All right. Now looking at b, we have the limit as x approaches 0 of the 1 minus cosine of x divided by x is equal to 0. Now, again, this is just another one that we'll have to memorize. If you want to verify, you can definitely plug this in the calculator and just make sure that it does in fact come out to be that. In fact, let's go ahead and do that. So I'm going to go ahead and clear. On top, we have 1 minus the cosine of x divided by x. Then going ahead and graphing this. That would be our image. And again, you can't go ahead and throw 0 in there, but that limit does exist. You can see that the left side is matching the right side at that limit of 0. So again, that's just kind of evidence of it. Now, let's go ahead and see if the same rule applies for the cosine as we did with just the sine. So I'm going to go ahead and just throw a number in front of the x. So let's go ahead and insert a number 2 in front of him. Likewise, we have to do it on the bottom. Going ahead and hitting graph, we see that we should end up with that same exact limit. So as long as those numbers are in fact matching, we're okay. So in other words, as long as these numbers are matching, like I just threw in 2, it should work out just fine. Now, how this is working for example 4a. Well, we're looking at trying to evaluate this limit as x approaches 0 of the sine of 3x. Now, unfortunately, if you try just doing direct evaluation, you'd get 0 over 0 in determinate form. So that's not going to quite work. You could graph this and just kind of see what happens, but let's say, for example, this is on the multiple choice, multiple choice non-calculator portion. Well, what do? A very, very quick and easy fix that we can do is going ahead and doing just a little bit of foo-foo. Back from Algebra 2, maybe you remember that, where you just multiply the entire top by, let's say, 3 over 3. Now, the whole reason why I'm trying to do 3 over 3 is simply because we have the sine of 3x, and I'm trying to get this bottom to have that 3x, such then that they match, where we have the sine of 3x over 3x, just like our definition says, as long as those numbers match. So once we do that, we end up with the limit, and we'll go down a little bit, as x approaches 0 of the sine of 3x times 3 all over. On the bottom, we end up with just x times 3. Well, that's just 3x. And so there's a couple of different ways that you can do this. Just from our definition, you would realize that this part is just 1 times 3, but a more formal definition that we've seen is that we can go ahead and take this constant, pull them out in front of the limit, So then we end up with 3 times the limit. I'm just showing the long way so we can, see it using the definitions. Again, that being that scalar multiplication with limits. And a moment ago we just said, as long as these two numbers match, then this limit as x approaches 0, the sign of these numbers matching, sign of x over that number matching x is just going to come out to be, again, 1. So ultimately we have 3 times 1, so our limit should just come out to be 3. So again, that is example 4a, and also just kind of verifying those like trig, those special trig functions with limits as they approach 0.